We've talked about how the independent variable in an experiment represents the different groups that are manipulated by the researcher. So then, how do we assign participants in our study to these different treatment groups? Sorry, I was on the wrong page there. We want to do that through random assignment. Random assignment means that all of the participants in the study have the same chance of being assigned to every group that's in the study. So this has to be randomly, or else there may be extraneous variables that interfere with the validity of the experiment. So you can't do it according to any kind of reasoning or logic, but it has to be so that every person in the study has an equal chance of getting into every different treatment condition. Random assignment. And we talked about the control condition, and in its simplest form, an experiment has at least a treatment group that receives some kind of manipulation, and then a control group that acts as a comparison. It's comparable to the experimental condition, except that it lacks the one type of treatment that is hypothesized to produce the change, to produce the effect. Sometimes the control condition is referred to as the placebo condition, and that kind of comes from studies that are done with medicines, where you are testing a medicine's treatment effectiveness, and you need something to test against, the results against, so you use a group of people that don't receive the pill, and in place of the pill, you give them a phony pill that is looks in every way like the actual pill that the other group is taking, but the participants are blind to whether or not they're actually receiving the treatment or not. So this helps us to be able to tell specifically, to pinpoint the cause to the treatment condition specifically. Now here's a different type of experiment for you where nothing is really manipulated. It's called a natural experiment, or some texts refer to it as naturalistic experiment. And this is where you take a naturally occurring event or phenomenon, and you compare you compare them, the results, with each other. So my example, what I use for this is the example of a study that was done in Germany when they were proposing to build an international airport, and the neighborhood that they were going to be building the airport in was worried because they thought that it would really be stressful, especially for the children. There were a lot of children located in the area. And politics being as they are, the airport was built, but they decided, well, we'll test this out and see if indeed stress levels do go up for the children that do live here. So they did that by taking a baseline measure of how much stress these children were experiencing before any kind of construction on the airport ever started. And then they compared that to stress levels that they measured after the airport was up and running for quite a while. So in this way, they didn't have to really manipulate anything. It was something that was going to occur anyway, but it did give us information, really good information about how stress like airport noise affects children, and indeed their stress levels did go up. External validity is a concept that's very important in talking about experiments. So this is an indication of how well the information you're going to get from your experiment, a lot of times in a lab setting, is going to generalize to the outside world in similar situations. So in our example of participants that have cognitive behavioral therapy, we want to know that there's good external validity in our study that would mean that patients that seek out cognitive behavioral therapy are likely in real life situations to have the same results. If it shows to be a positive treatment effect, we would want that to generalize to the population outside of that experiment so that it can do the most good for the most people, and really the reason why we kind of look at these issues. Another type of an experiment is called a field experiment. So rather than being conducted in a laboratory, it's conducted out in the real world. So usually the participants in a field experiment are not aware that they're even in any kind of a study. So it's kind of a combination experiment, naturalistic observation in a way. So we want to see how people respond in the real world. An example, kind of a fun example of a field experiment was a study that was done where they observed how long people take to back out of parking places and crowded parking lots when people are waiting for them to pull out. And so they, in this particular study, they had 3 different conditions. The first condition was a control condition where they just observed how long it took people to leave their parking places once they got in their car, with no kind of interference, nobody coming and acting like they wanted the parking place. And then the second condition was they had somebody drive up behind them when they saw the person get in the car and put their signal on and just wait quietly. That's what I usually do. And then the third condition was they had somebody drive up behind the car that was getting ready to leave, put their signal on, and raise their hand out of the window and kind of yell and encourage them to hurry up, you know, or make some gestures. So it's kind of a rude condition. And they did find differences in these, significant differences in these different conditions. Even the relatively, the person that we would think was being really courteous with just the signal on, waiting there quiet, there was a significant increase in the amount of time that it took the driver to leave, and a very longer time with the group that was rude. So you can see that field experiment has quite a bit of external validity because it actually does take place in the real world. So as well as external validity, another important concept when we're talking about research and experiments is internal validity. And internal validity represents the confidence that the variable that we manipulated, the treatment, could have produced the results, and that nothing else, no extraneous variables that we didn't think of before caused the results. And a common test for internal validity is to replicate the study. So it usually isn't enough to just run an experiment and establish a cause-effect relationship and leave it at that. In science, in psychology, we always want to do the study again. Try to see if we can replicate the results, because that gives our information a lot more, in the conclusions we come to, a lot more validity, a lot more strength, the more it's replicated. Our book talks about the importance of debriefing in experiments, either during the preliminary stages of the experiment and in particularly after an experiment is conducted. So in developing an experiment, debriefing involves asking the people participating directly if they understood what the directions were, if they thought that it was a reasonable kind of design for the experiment, asking them their opinions about it. And in later versions, after the experiment is solidified and results are in, Debriefing is about educating the participants about what the question actually was being studied. And sometimes participants know that because they're told that through informed consent before they even start the study. But oftentimes deception is used. So sometimes we actually can't get the answers we need about human behavior if we let people know what it is we're studying. So in those cases, deception is used. And participants then are misled about what the purpose of the study is and what kind of information we're trying to gather. A good example is Stanley Milgram's study with, I call it the teacher-learner experiment, where they had the guy in the lab coat instructing the participant to give shocks to a Confederate participant that was thought to be receiving the shocks. And the informed consent, they actually told these participants that they were going to be trying to learn more about how people learn and memory, that was the point of it, when in actuality it was really all about obedience, and specifically obedience to authority. So very different type of focus than what the participants thought. And then also debriefing includes trying to leave the participant in a good frame of mind so that they're not harmed by the experiment. Debriefing includes that. I've already talked a bit about replication. Here's your definition of reproducing the results of a scientific study, and it's very important in psychological studies. And sometimes when replication doesn't take place, there's a lot of accusations that the researchers really didn't do a very good job in designing the study, and their results are called into question. So a really important piece to include if you're any kind of scientist, because replication ensures that you can have confidence that your independent variable is really having an effect. We're going to close looking at a couple of strategies that are often used in either observational or correlational research. The first one is longitudinal studies. And in longitudinal studies, the same individuals are studied across time at different parts of their life. And an example of this is in your book on page 52. This image is a picture of people that have been studied across time since 1964. And it's a documentary film by Michael Apted, A-P-T-E-D, if you're interested in looking it up. And it's a Up series documentary that traces the development of 14 Britons across their lifespan. You can see them holding pictures of themselves since they began in 1964 and how they've changed throughout the years. And then another type is of strategy used in observational and sometimes correlational studies is called cross-sectional studies. And cross-sectional means that individuals or groups are studied in one point in time and then compared, that information is compared to individuals or group of a different age or a different developmental age. It's often a strategy used in developmental psychology. And an example of cross-sectional is to study the effect of aging on cognitive functioning. So you might compare memory abilities in 45-year-olds, 55-year-olds, and 65-year-olds, looking for age-related differences that you can then generalize to the public. Thank you very much, and I hope that you're all doing well with your studies for Chapter 2.